Welcome to my channel, and um, nice having you guys here with me. I would like to talk about Bitwise in C programming. Actually, we have it in other programming language. We'll be focusing more on C. So we'll see how we can manipulate Bitwise, and we're going to understand the basic steps. So we'll be able to answer this quiz from 1 to the end. Actually, it's very simple for you to read and understand. We're going to be talking about the um, OR gate, NOR gate, um, NOTs, and the shift left, shift right, and other stuff like that. Amazing stuff that we have in Bitwise. So please make sure you stay tuned and don't miss any of these parts. Then later on in this course, we're still gonna be um, um, using this to solve issues to see how we can apply it in a real life situation. We see how we can write functions that can convert from binary to decimal, from decimal to binary, and so on. So first of all, let's get started. So the first thing we have here is we have our, when you take a good look at this, we have two values, which is A, and we have another one which is B. So let me use my pen to mark that out. So we have this A, which we have here, and we have B, which we have here. So there's a difference between a bit wise uh, operation and a logic operation. So a bitwise operation, although we have the slash slash like this, which means or, and we have the and sign, this and sign, like two bits. We have this, which means something like the two things must be true, or two conditions must be true. So but we are not going to talk about logic, so we are focusing more on these ones. So let's go ahead to talk about the bitwise operation. So the first operation we have there is this operation, which is known as or is known as or. So that is what this operation really stands for. So we are going to see how to use it. They all simply means that any of these condition must be true. Is either A is correct, or the B is either A is true or B is true. At least one of the two arguments provided should be true. That's what is about. So either A or B should be true. Among these two, one must be true. So before that, conditions can be marked as 1. So for instance, we have 0 here, and we have 0 here for this first part of it. So we have 0 and 0. So for that, now those 0 and 0, it will come here and check. Is A 1? No. A is 0. Is B 1? No. It's still 0. So it's going to give you a 0, which we have there. So it's going to check again for the next one. Is A 1? No. It's 0. Is B 1? Yeah. B is 1. So at least each of any of those should be 1. And if any of those is 1 is true, then it should execute, just like the OR function. So for instance, I'm saying if Ade and let me put two names like Taye and Kende. If Taye have the pen, then they can both enter. But if Taye and Kende none of them have the pen, that means none of them can enter. So it's either one of them, is either Taye have a pen or Kehinde have the pen. So we'll consider it as a true. So let's assume that one simply stands for true, then 0 stands for false. So this is true and this is false. So it's either Kehinde is holding a pen, even if the other one does not have the pen, will still accept you to come in, or Taye is holding the pen, even if Kehinde does not have the pen, will still allow you inside. It's acceptable. Or probably the both of you might have the pen, so both Taye and Kehinde can have the pen, so you can still enter inside. But in a situation whereby none of you have a pen, so it is not possible for you to enter the examination hall. So that's what the OR gate is for, and it's represented with this sign. So I hope you guys understand that. So the next one we're going to be talking about is the AND gate. The AND gate is represented with this operand like this. So I'm trying to draw that out. It's not easy. Okay, so it's represented with that sign, which is for the AND, A-N-D, like that. So that's what the AND gate is represented. So I'm going to get rid of that. So you can see that. So that one simply says that at least for me to accept that a condition is true, that means either of them must meet that condition. So if both of you are false, I will take a false, which is this one here. Else, if one of you have pen, maybe Taye and Kehinde, Taye have the pen, but Kehinde does not have the pen, the both of them will not enter the examination hall. Or Kehinde have the pen, but Taye does not have the pen, both of them will not enter the examination hall. So for them to enter the examination hall, both of them must have a pen. So which is true. We have 1 here. So you can see that. So both of them make sure that they have a pen, which is this one we have over here. So that is for the pen. Now the next thing again we're going to be talking about after the AND gate is we're going to be talking about the I think we can call that OR gate. So we can just put XOR coming. So the XOR, so just like this, X, then O, then R, like this. So I hope you understand that. Okay, so now the XOR, let me get rid of that. The XOR is, for instance, we're talking about the other parts. So if for instance we have O and we have E, so it's either we choose the ones that either have the correct syntax. So for instance, we have if both conditions are met, we are going to give the opposite, except one of them is not met. So for instance, Taye and Kehinde does not have a pen. So let me see if I can use that as a good example. So assuming Taye and Kehinde does not have a pen, so they can't enter. Or Taye and Kehinde have a pen, they can't still enter. But if one person have a pen or the other person have a pen, okay, good. I've seen a very good example that I can use for this. So for example, we have a wedding party, and it's only meant for couples. So let's assume that 0 stands for a female, then 1 stands for a male. So this is a female and this is a male. So just as an assumption. So if for instance in the party we have one male here and a female, they enter the party, they are allowed to enter, or this other one and this one, as far as they are male and female, they are permitted to enter, so they are going to mark it as 1 1. But in a situation whereby is two females trying to enter the party for married couples, they might ask them, hey, where is your spouse, or where is your husband, or two guys entering and they say, hey, where are your wives? So they are not permitted to enter, so it's marked as 0 or 0. So you can see that example I've cited there. So that's a very good example. So if conditions both are true, it gives a 0. So we can invariably say that it is the opposite of the AND gate. So this is the opposite of AND gate. So this sign, I don't know how to draw. So I'll try that again. So let me try that again. Okay. Is the opposite of this. So this is the AND gate. And this is the NOT gate, XOR, sorry, gate. So they are opposite. So if this is, we have something like 1 in the AND gate, is going to be the opposite, which is going to be 0. So you get that. So take note of that. So the next thing we're going to be talking about is the NOT gate. The NOT gate. So the NOT gate is represented with a T-dial sign like this, a T-dial sign. So you can see the sign which is over here, the one for A. So what it does simply means, it simply does, it is used to oppose signs, is used to oppose symbols, anything that has to do with opposition. So for instance, we have 0, 0, 1, 1. So it's going to be the opposite, which is 1, 1, 0, 0. Can you see that? Or let me get rid of this. Or for B, we have 0, 1, 0, 1. So the B T-dial is going to give us 1, 0, 1, 0. So it only work with one operator, one value, or it only accepts one argument, which is A. So that's it. So I hope you understand that. But if you have any question about the explanation, you can drop that on the comment box. So we'll talk about that. For the ones we don't have here, I'm gonna be talking about it too. We have the left shift and the right shift. So we have something like this, which is the left shift, and we have the right shift. Still part of this. So I'm gonna be explaining that in sheet. So let's get rid of this. So I'm gonna open a terminal so we can see that. Sorry. So let me open my terminal because that will be clear on the screen. I want to get rid of this, so I'm gonna say clear like that. So we have a clear screen. Getting rid of this. So I'm going to be typing whatever I'm typing here. I'm going to be writing whatever I'm writing here. Okay, so let me change the color to a white. Good. So it's be the opposite. Okay. Sorry for that. this. Let me reduce the pin size. Good. Okay, so let's get started. So the next thing we're talking about here is the left shift. So the left shift, for instance, we have an operation which is maybe for instance we have T as our operation, and we use the left shift, which is this left shift. Then we have another operation like 2 here. So now the operation we have here simply stands for the value. It might be in bit, it might be in decimal, but I'm shifting it to the what? I'm shifting it to the right. So let's start. I'm going to be shifting it 2 bits. So for instance, we have for instance, we want to represent this. This is in this thing. I want to convert this to a decimal. So I think in secondary school we have been taught how to convert from decimal to binary. So let's assume we want to convert this tree to binary. So permit me to convert that in a short while. So I know that we taught this maybe in just 1, just 2, just 3. So we have this like this. Then we now have 3 here. Then we now have 2 here like that. So you can see what I have here. So now I want to convert this to base 2. So 2 divided by 3. So that is, it goes into its 1 remainder 1. So I go again, 2 divided by 1. So it cannot go into it. So I'm going to drop 0. Then it's going to be remainder 1. Sorry, come here. 1, which we have here. So we have 1 as our final answer. So this is our final answer. Okay, so I'm going to get rid. So remember that 3 stands for what? 1, 1. So I'm going to get rid of all the stuff here we have on the screen. Good. Now, the next thing we're going to do is we're going to note that as a programmer, we operate in 4 bits. So, for instance, we want to represent this in a format. You're going to start with, it's going to occur in a 4-bit. So we have the first bit here, which is going to be 0, 0, 0, 0. Oh, that's off the screen. Sorry, permit me to do that again. So we have 0, 0, 0, and 0. So you can see that this the first character, second, and third, and fourth. So we have 4 stuff there. So whatever each number represents this 4 bits. Each number represents this 4 bits, especially when you are operating maybe in hexadecimal or octal. Depends how you run it, whether you're working 8-bit or 4 bits, whichever one. So we're gonna get started. So we know that 13 what gives us what? It's gonna give us 1 1, which is kind of 11, but 1 1. So you're gonna start from here. So you're gonna say 1 1. So you're gonna fill in the gap or the remaining space with what? 0 0. So you can see that. So another one is coming. For instance, I have 4 here. So let me put 4. So 4 in binary is what? People put 4. So I'm just doing this so that we know what is going on there. Know how we get those numbers. So if for instance we have 4, I want to convert 4 to base 2. So 2 goes here. That's what? 2 remainder 0. 0. 2 goes here. 1 remainder 0. Then 2 again here. That is 1. and that is 0 remainder 1, I mean. Okay, so we now have 1 0 0, which is here 1 0 0. So we have 1 0 0. So if we want to represent this, we want to represent all this. To represent it is, you represent it this way as 1 1 I'm putting it 1 0 0. Then it's not up to 4, so you're going to add 1 0 here to make it in 4. So you're working in 4 4 4. So now let's talk about the main stuff, or the main topic here. So we have 4 here. Now this 4, we're gonna be shifting it to the left twice. So if, for instance, okay, sorry, we're talking about 3 that time, so let me put the 3 back. So we say 3 stands for what? 11. So if we want to put this in the normal format, presentation is going to be 0 0 1 1. We have 0 0 1 1, like that. So if I shift it 2 times, so whatever that I have beneath here is going to be represented. So if I shift it once, okay, let me shift it once so you see what's going to happen. So if I shift it once, coming, let me make it a little bit smaller so it can contain the screen. So we have 3 here, and I'm shifting it to the left once. So the original value of 3 is going to be 0 0. Then we're going to be having 1 1, like that. So shifting it once like this is going to be what? It's going to give us 0. So where this 0 is going to be 1 1. Then the place where it was shifted to is what? 0. So here it's going to be represented with 0. So you can see this first value is truncated. So another value is added here. So we have shifted once. You get, make sure it is 4 number 1 2 3 4, like that, 4. You can see what we have there, right? So if, for instance, I want to shift it 2 times, so we have something like this. For instance, we have 3. I want to shift it like 2 times. So you see, this is what is going to happen if I shift it 2 times. So we're going to have something like, it's going to give us something like 1 1 0 0. You see that? So it has moved twice to the left. You can see that. If we move it like 3 times, so like that, 3 times, you see it's gonna be what? 1 0 0 0. So you can see that. Now each of these has a value. For instance, 0 1 1 0 is going to give us 6. So this is 6. This 1 1 1 1 0 0. So I think this should be let me see, 1 2 4 8. So that's going to be 12, if I'm not mistaken. Yeah, it's going to be 12 if I'm not mistaken. Why this is 0 1 2 4 8. So here is going to be 8. So this is going to give us 8 as our final answer. So I'm going to get rid of this and put 8. So instead of us having this, the outcome is going to be 8 here. Then for this particular one, which is what we have here, for this one, the outcome, I think we have 1100. That's going to be 12 there. Then for this that we shifted one, get rid of this. So yeah, the outcome is going to be 6. So you can see that the outcome is 6. So we have 6, 12, 8. We have 3. So you can see how it goes. And if we shift it to 4, to the left, everything ends up being 0, 0, 0. And that's it. If we are operating only on a single value. So that is the concept of shift left. So let's talk about the shift right. So the shift right, for the shift right is represented with this symbol, something like this. So it's going to be shifting right. So the shift right, okay, before okay, let me just go the shift right, then I'm gonna give you a simple tricks of calculating those with ease without wasting more time or much time. You're gonna see the secrets behind those stuff. Okay. So now, for instance, we have the 3, then we have this set by 1. So if, for instance, 3 stands for what? 0, 0, 1, 1, that's the value of 3. Then I shift it to the right. This last value here is going to be truncated, so we're going to have something like 0, 0, 0, 1. You can see that because this has shifted away from the bit. So this other one has added another 0, and this is being removed, like remove. You can see that because it shifted like this. So you understand the concept. So it's just like the opposite of the other one. If, for instance, we have we shift it twice, maybe I shift it like 2 times, and we have 0, 0, 1, 1, and shift twice. So we're gonna end up having 0, 0, 0, 0. See, nothing is there because it has been shifted twice to the right hand side, and we end up having 0, 0. The remaining ones we have here, so this will be truncated, then we now have extra 0 added to it just to make sure it is in 4 bits. So we have extra 2 zeros added to it to make sure it is in 4 bits. So that's the logic here. Okay, so we are meant to answer some quiz after I have explained these basic concepts. So I'm going to be going back to where our question is. We get to see some of the stuff that we can do, and at a long I'll be explaining some basic stuff to us so we can see how to get across and answer some difficult aspect of this. So that's the aim. So the first is have here after this much explanation. The first thing we have here as our quiz. Okay. So I'm gonna open this so you see what we have there. Okay, you can see what we have here. What is 0x89 in base 10? So actually, sorry, I've forgotten to add this to it. The simplest way to identify which is an hexadecimal number, because for in real life situation, we should know that if, for instance, we are operating in base 8, sorry, in base 2, we start with what, 0 and end with what, 1. So for instance, base 2 is going to be 0 and 1. So we only have 2 numbers there. So base 3 is going to be what? 0, 1, and 2. So we only have 3 numbers there. So base 10 and so on is going to be what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we don't have 10, but make sure that it's 10 number. If you count that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that. So that is for base. So if for instance we have base 7, that means our number is going to be ranging from 0 to 6. You understand that? So it's just like modules operation. So it has a limit. We are operating in mode 1, mode 2, mode 3. So it's going to be ranging from 0 to the number before that number. We don't always have base. We don't have 10 in base 10. We don't have 2 in base 2. We don't have 3 in base 3. We don't have 4 in base 4. So it's always number beneath or below it. Okay. So, for instance, we have 9 in base 10. Good and fine. But we also have 89 in hexadecimal, which is base 16. We have base 16. It's also known as hexadecimal, base 16, known as hexadecimal. And this is known as decimal, which is base 10. Now, both of them have this value of 8 and 9 because if we are to say we want to be counting from and we want to be using base 10, we are going to see that in base 10 we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but we don't have 10. So that is in base 10. You see, we still have 8 and 9 in base 10. Now let's check base 11. Base 16, I mean. Let's see what's going to happen. In base 16 too, we also have those stuff there. Starting from, let's go over base 16. We have 0, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, but we don't have 10. So instead of putting 10 there, we have A. That's representing 10. We have B. That's representing 11. We have C. That's 10. Sorry. That is 12. We have D. That is 13. We have E. And we have F. So F. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. F, 16. Then we go over to other values like 17, which is going to be addition of both letters and numbers. So let's stop here for the range, but we can still move further than that. Okay. So let me get rid of this. Okay, so you can see that both that 16 and 10, base 16 and base 10 both have 8 and 9. So how can we differentiate that of what? 16 and differentiate that of 10? So we come up with an idea to differentiate between 16 and 10 is, firstly, if it is ordinary 10, like if it is ordinary, it is ordinary 89. Let me put my pen back. Good. So if it is ordinary 89, we're gonna have, this is in decimal. In decimal, we are going to have what? 89. But if it is in base 16, which is hexadecimal, we are going to be having this. We're going to be adding something which is 0, x, 8, then 9. Like that. You can see that. So this has differentiated that this is for the hexadecimal and this is just 89, which stands for 89 for the decimal. So mainly most of us make use of this hexadecimal, especially some errors you might encounter and you see 0x and something this thing error message. You might see that in your computer. So we start with 0x. We see this in color, hexadecimal colors like ash 222. When you are working with CSS, you see colors that have, you work with hexadecimal, and much more. This is very vital when it comes to programming. Other aspects which is very important we're going to be discussing later on. So that is the difference. So when you go back to that question, you see that um, the value that was there is not in base 10, so it is in hexadecimal, and we are asked to convert the hexadecimal value to base 10. So we're just gonna wait for that to come. Okay, good. Uh, good. We have 0x89 in base 10. So we're asked to write this in base 10. And how can we do that? To write this in base 10 is very simple. Very simple. So we know how to be in school if we want to count in base. Let's give 0. Coming. So in school, we're taught how to convert from any base to base base 10. So if, for instance, I want to convert from base 2 to base 10, for instance, I have, they say convert this 101 to base 10, and we ask to convert this. What we do is we're going to put 0 here, we're going to put 1 here, and we're going to put 2 here, like that. You can see. So at the end, we'll now come and say from this first one, let me start there. Normally we're supposed to start from the last one, but I'm starting here. So from this first one, I'm going to have 1, which is that one we have here, times, because it is in base 2, I'm going to put times 2, raised to the power of what we have, what I've written up here, raised to the power of 2. You can see that, and I will say plus, see, plus the next one, which is what, 0, which we have there, times, then because we are working in base 2, so it's going to be times 2 raised to the power of what we have there, which is 1, then plus 1 times 2 raised to the power of what we have there, which is going to be which is going to be 0. So at the end of everything, this is going to give us 1 times 2 raised to the power of 2, that is 2 times 2, that is 2 raised to the power of 2. 2 times 2 is going to give us 4 times 1, which is still 4. So here is going to be 2 raised to the power of 1, that is 2. 2 times 0 is still 0. Then this one too, the same thing, 2 raised to the power of 0. Anything raised to the power of 0 is 1. So 1 times 1 is still going to give us 1. So you're going to be adding 4 plus 0 plus 1, which is going to give us what? 5. So you understand the concept. So the same way we do this is applicable to any conversion of any base to base 10. So you can see that is applicable in any conversion at all. Any conversion, when we say any conversion, I mean any conversion, whether you're converting from base 8 or you're converting from base 7, 4, 2, even base 1, sorry. So any conversion at all you are converting, you use that format. So we have 0x89. So we are gonna be we are not going to look at this because this is not important, but it's just to signify that that's an hexadecimal number. So whenever you see this, what should come to your mind, that is base 16. So whatever I'm working on in this number here, it should be base 16. So the same thing we're going to apply here. We have 8, which is the first number. So don't forget to put your this thing, calibrate your numbers. So this is going to be 0 and this is going to be 1, like that. You can see that. So we're going to have 8 times, we are working in 16, base 16, so it's going to be 8 times what? 16 raised to the power of what? 1, right? So the next one is 9, so we have 9 times what? 16 raised to the power of 0. So let me remove this so it won't confuse us. Good. That 0 looks weird. Write the 0 well. Okay, so you can see this. So we're going to be adding these two stuff together. So the first one is 8 times, so 16 raised to the power of 1 is still 16. 16 times 8, I think that's going to give us 16 times 8. Coming. 16 times 8. Let me calculate that way, because I'm not good at calculating stuff with my head. So that is 666, 36, 42, 42 plus 6 again, that should be 48. I'll put 8 there, put 4 here, so 12, 128 plus, okay, so that's going to be 128, so I'm going to put that as 1, 2, 8, like that. So that's for this other one we have here. Then the next one again is 16 raised to the power of 0. 16 raised to the power of 0, anything raised to the power of 0 is 1. So 1 times 9 is still 9. So I'm going to be adding it with 9. So 128 plus 9 is going to give us what? That is going to give us a sum of 128 plus 9. You're going to add this to that. So that's going to be 137. 137, like that. So you see our answer is 137. So if you go to check, we should have 137. Let me get rid of this. We should have 137. So let's check that out. So I'm going to be putting the answers up. So we don't need to be checking this. So you can see, wait, the quiz, it's not showing up. So you can see, oh shit, we have 137. You can see that is what we have here. 137, 137. So that's settled for that. I've forgotten that I was using white. Let me change it to red. Okay. So you can see we have 137, which is the correct answer. So that is that. So the next one is, what is 0x89 in base 2? So we are done converting it to base 10. Now we want to convert hexadecimal to base 2. And I'm going to show you the simplest tricks where it works for. Don't forget, I made mention that each of value has to be a bit of let me get my pen set. So have to be in a bit of 0, 0, 0, 0. You can see 4. So that's what we're going to be working with. So we're asked to convert this 0x 8 what 9 to base. We have to convert it to base. So like that, we're going to convert that to base 2. So to do that is also simple. If you want to do that, we're going to go ahead and, okay, sorry. So we're going to go ahead and do that right away. So you know that we have 0x. So to represent this in a binary format, you're just going to use your O and B to represent that in a binary format. That means that's been converted from a hexadecimal number to a binary number. So we should take note of that. But we're going to be focusing more on that. So just focus, our main focus should be on the 8, 9. So that's where our main focus is. So we're going to be slashing into 2. So the first one we're going to be dealing with is 9. So what is 9? If you check 9 in your binary this thing, let's draw that. 2 and 9. So 2 goes into 9. Let me move this down here so it won't interrupt. So 2 goes into 9. That should be 4. Remainder 1. You can see that. 2 goes here. That should be 2. Remainder 0. 2 goes here. That should be 1. Remainder 0. And 2 goes here. That should be 0. Remainder 1. So under 9 we have 1, 0, 0, 1. You can see that. So you count from up to the top as you were taught at school. So you can see we are applying what we were taught at school here. That's very important. So you make sure you make use of every important information. Everything you were taught at school are very important because you're going to be using those things, especially when it comes to programming, when it comes to software engineering, mathematics, you're going to be applying that. So this for 9. So this for 9, so I'm going to put it there to indicate 9. That's for 9. Okay. So let me arrange that. I'm gonna be cleaning this, so remember that's 1 1. So we have 8 here and we have 9 here. So that for of 9 is 1 0 0 1. So I want to do that of 8. That of 8 is going to be 2 8. 2 goes into 8. That is 4. Remainder 0. 2 here. That is 2. Remainder 0. 2. 1 remainder 0. 2 again. 0 remainder 1. So it goes up like this. And we have 1 0 0 0. So here is going to be 1 0 0 0. So you can see that. So a bit of 4. Yes, 4. Yes, 4. So we're going to combine all this stuff together to give us our final answer. So you see, I treated each value individual. I treated each value as a unit, as a bit. So our final answer is going to be 1, like this: 1 0 0 0 1 0 0 1. That's going to be final answer. So because it has the x here, so we are going to put our OB here, like that. That's B, not a 1. O and B. So you have your OB fixed there. O, B, then we have the remaining numbers there too, like that. So you can see, so if we're going to check what the number there is, let me get rid of that. You see that we have given a solution to the other. Okay, so going over there. Well, so show the quiz. So I think the number one, number two, and more of tax, and so we have done question number one, which is gonna be which is the correct answer. You can see that we have the correct number there, which is this one here. So we have 1001, which represents the 9, and 1000, which represents the 8. You can see as simple as ABC. So the next question here is, what is 0010010011? What's gonna be that in base 10? So I think we're gonna work that there here, because this should be very simple. So we're gonna pick the first four numbers, starting from the back side. So we have 0010, which are these numbers we have here. So which numbers is always like this? This should be base 2. This should be number 2. Let's take a look at that. Let's confirm to see if it is number 2. So if you're working in base 2, for instance, this is base 2. Base 2. Want to convert 2 to base 10. 2 goes into 2. That is how many times? That is 1. Remember what? 0. Then 2 goes into 1. That is what? 0 remainder 1. So you can see we have 10. So this 10, normally it should be what? 1 and 0, like 1 and 0 like this. But based on the fact that we are dealing with hexadecimal, so we're going to be adding the remaining 2 zeros to make it complete. So this should represent 2. So we'll look for the one that have 2. So I think this should be the correct answer. So let's look for the remaining ones before we assume that as our final answer. The next one we have here is this number starting from here. Oh shit, I have not put my pen tool. Okay, so starting from here to there, which we have 0, 1, 0, 1, like that. So if you can see that, to check this out, this should, let me see, this is a 1, this is a 2, and this is a 4. I think they should add something there. But based on the fact that we have how many numbers? 1, 2, 3, 4, 5 there. So you're going to be converting that. So we have a 2 here. This is how many? 1. 1. Here is what? 1, 2. So this is 5. That is going to be 5, 2. So you can see that we have 5 and 2. So we're going to be convert this because this is a hexadecimal number, 0 and x. So we're going to be converting that to what? Base 10. Converting that to base 10, this number to base 10. Let me get rid of all this stuff we have here. Converting this to base 10 as we did previously. The first one is going to be times by what? 1, which is going to be 2, and the next one is going to be 16. So 16 times 5 is going to give us what? 16 times 5. So 16 times 5. I think by 10 that is 50. Then by 6 that is 30. That should be 80. 80. So 16 times 5 is 80. Then 1 times 2 is going to be 2. So like that. So I'm converting this value back to decimal. So as we did previously using the normal stuff there. So we should know how to do that because it's very simple to understand this simple logic. So you add this, it's going to be 2 and this is going to be 8 like that. So I'll push this guy here. Okay, let me drag this guy over to this. Good. So all of them will be on one side. So that's for the base, this binary, which is hexadecimal, from converting it to base 10. The first thing you do is to convert it to hexadecimal, which is going to give us what? 52. Then you're going to convert 52, which is a decimal number, to base 10, which is going to be what? 5 times 16 raised to the power of 1 plus 5 times 16 raised to the power of 0. So 16 raised to the power of, 2, not 5. Mistake. 2. So 16 raised to the power of 0 is 1. 1 times 2 is still going to give us 2 plus 16 raised to the power of 1 is 16. Then 16 times 5 is going to give us 80. So which is going to give us 82. You can see that. So that's the simple logic there. So that's that for question 2. Then for question 3, what is 0 OB 011 011 01 in base 16, which we're going to be treating right away. Starting with that, the first thing we're going to be doing is we are going to do the same. This already is in hexadecimal in binary. So what you just need to do is you count the first 4. Let me put my pen tool. The first 4 numbers, which is what? 1101. So 1101, that should be what in binary. So this is 1, 2, 4, and this 8. So 2 is rubbed off because it comes with 0, so it's meaningless. So what we have there is 1 plus 4 plus 8. 1 plus 4 plus 8, that should be 13. So we have 13, which is the first number. So we have 13 like that. That's for this first part. Get. So for the second next 4 numbers, which are these 4 numbers, starting from here to that place, we have what? We have 0, 0, 1, 1, 0, which is the next four numbers. And I probably think this should be 6, because you calculate it, this is 1, 2, 4, 8, like that. So this is rubbed off because it's on top of 0. So what we have here is 4 times 1, which is 4, 2 times 1, which is 2. You add them together, that is going to give you 6. So the next one we have here is 6. So now we see that we have 6 and 13, which is our answer for those two numbers. But you notice I made mention that in base 16 we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then when it gets to 10, instead of 10, it was replaced with what? A. So 10 stands for A, 11 stands for what? B, 12 stands for C, then 13 stands for D. So invariably, 13 will be what? D. So we're just going to put D there, then we're going to put 6 here. So you can see that. So we have 6D. So you can see our answer is over here, which is the 6D we have here. So I hope you guys understand that. So, for the next one, asks what is 98 in base 2. So what is 98 in base 2? So the same thing we have been applying throughout the whole stuff here. That's what I'm going to be doing here. So what's 98 in base 2? So that's to tell us that when this sign is given to us, this 0b, that means this 98 is a hexadecimal value. So we're going to be converting that to a normal value. So that's what is coming up here. We're going to be converting that to a normal value. So we're going to start with 8. So 9 8s, let us convert it to base 10 first. Or before doing that, let's convert it to hexadecimal. So we have 9, 8. Okay. So let's do this. For instance, we have 0 here. We have 1 here. So 0 and 1 there, because note, this is in base 10, not hexadecimal. So we're converting to base hexadecimal before we'll be able to convert it to this. So I told you the difference between this 98 and the one that has 0x is the one that does not have 0x is base 10, but the one that has 0x is base 10. So please make sure we don't forget that. So I'm going to convert this to base 16. So 8 times, sorry my pen, 8 times 16 raised to the power of 0, that is for this one, plus 9 times 16 raised to the power of what? 1. You can see that. So 16 raised to the power of 0 is 1. 1 times 8 is still 8, plus 16 raised to the power of 1 is 16. 16 times 9. 16 times 9. I'm coming, let me use my pen and paper to do that. 16 times 9. Or 9 times 6. That should be 54. 54. So we have 4 here, we have 5 here. Then 9 times 1, that should be 9 plus 5, that is 14. That is 144. 144. So we have 144. So we get that. So we add the 144 plus the let me sure I'm doing the right thing. 8 times 16. Okay. Okay, 144 plus the 8 we have there. 144 plus the 8 we have there. This is 8 plus 4 is 2, carry 1, 5, then 152. So we have 152 there. Okay. So we have 152 there. So the 152 we have there, we are going to be converting it to the actual value. 152, let me put that down. 152. So the 152. So what I'm going to do next is we are going to pick them individually. So, oops, I think I'm not making a mistake here. Okay, I think I should convert this to binary. So let me see if that works. Okay, sorry. I'm converting it to base 16, but sorry, I've made a mistake, so just permit me to rectify that. I'm converting base 10. Converting base 10 to 16 is very simple. What we just need to do is just divide this stuff. So this thing, because I really made a mistake there, so sorry for that. It's just a straightforward thing. So because we are doing converting to any base, from base 10 to any base, we are going to use this. So converting from base 10 to any base, we use this cross sign. So please don't join me to forget. So we have 98 there. Then we have the base we're going to be breaking down with it. So so we go ahead to do that. So 16 goes into 98. That is 6 times remainder 2. So I don't know if I can squeeze that remainder 2 here. So remainder 2. Then we'll see you 16 again. 16 goes into 6. It cannot, so we'll put 0. Then this 6 we have here, we're going to repeat it here, which is going to be the 6 there. We have 6 there. So we now have, take it up there. So we have 6 and 2. So we can see that which is the 6 and 2 we're talking about here. So that's for this particular quiz. So for those of us taking time to answer that, that's the main stuff there. Okay. Now we are in the bits part of it where we're gonna be doing some logical reasoning. So we have 2 values, so we're gonna be forgetting about not mining this 0x and 0x we have here. So what we're mining is 0 and 1. It has the AND gate. So just permit me to use that 0 and 1. You can see that. So if you can remember, like what I said, I say for the AND gate, both of them must fulfill it. So this and this, they have fulfilled the promises. So it's a must that two of them must fulfill their promises. So it's going to be 1. 0 and 0, fulfilling promises, no, so it's going to be what? 0. So we have this as the correct answer. So for the next one, we have the same thing too with the or sign. So we have 0, 1, then 0, 1. So this one is anyone, at least one should just make sure you have a pen. So is either you have the pen or kind of have the pen. So this, let me put the or sign here, make it kind of bigger, or sign. So both Taye and Kande, the condition is met, so they can enter the examination hall. But these guys, 0, 0, none of them meets the condition, so we end up giving them 0. They are not entering the examination hall. So that's for that one. Then for the next one, we have 0, 1. We have 0, 1, then 0, 0, and they use the AND gates. AND gates. So what happens? This meets the condition, but this does not meet the condition. But for this examination, both of them must meet, so we give 0. This did not meet the condition, and this did not meet the condition, so we still give 0. So you can see that. That's for that one. Then for number 9 question, we have 0x1. So we have 0, 1. Sorry for that. So we have 0, 1, and we have 0, 0, like that. So those two. So one at least must meet the condition, because this is the OR gate. So 1 or 0. So this one of them meet, at least Taye have met the condition, so both of them can enter. But this both Taye and Kende, none of them brought their pen, so we give them 0. That's that for that one. Then for question number 10, we have 0x66 and 0x22. Okay, so we are going to be a bit logical with this. So we're going to be spraying this out, 66 and 22. So 6 in binary stands for what? It's going to be 0, 1, 1, 0. That's 6 in binary. You get that? So I'm going to use it vertically this way, so you understand what I'm talking about. So make my screens vertical. So what I'm saying is we have for 66 is 0, 1, 1, 0. So 1, 1, 0 stands for 6, as we said previously. Then another 6 is 0, 1, 1, 0. That is 6, 6. Now the next one is 2, 2. 2 is 1, 0. Then we have 0, 0. That is 0, 0, 1, 0. So we're going to do the same thing to here. 0, 0, 1, 0. Like that. So you can see what we have there. So if one evaluates it using the what? Using the AND gate, that means two people must meet the precaution. So starting with this first one we have here, 0, 0, none of them meet it, so they cannot enter. 1, 1, both of them, both Taye and Kende meet it, so we drop 1 for them. 1 here, Taye meets the condition, but Taye does not, Kende does not meet the condition, we drop 0 for them here. This meets, none of them meet the condition, we still put 0 for them here. Come to here, none of them, we still put 0 for them here. This both of them meet the condition, which is for this one, so put 1 for them here. Then this and this, one meets the condition but the other one did not meet the condition, so 0. And this one too, the same thing, so 0 for them. So we're going to count 1, 2, 3, 4. So we're going to slice it like that. So you can see, so 0, 0, 1, 0 stands for what? 2. Remember, this 0, 0, 1, 0, so this is 2. 0, 0, 1, 0 stands for another 2, which is this 2 we have here. You can see that. So we have 2 here and we have 2 here. So the answer is still 2, 2. So that's the correct answer, which we have here, 2, 2. So question number 11, we have 4, 4 and 2, 2. So let's check that out. 4, 4 and 2, 2. 4, 4 and 2, 2. 4, 4 and 2, 2. So 4 in binary, I can remember 2 is what? 2 is 0, 0, 1, 0, that's 2. Let me draw my line here. 0, 0, 1, 0. Then 4 should be, let me check 4. Let me do a quick calculation here. 2, 4. Because I always forget things. 2 goes 4 here. That should be 2 remainder 0. 2 goes here. 1 remainder 0 and 0 remainder 1. So that is 1, 0, 0. Okay, so let me get rid of that. 1, 0, 0. Okay, so 1, 0, 0. So let's go ahead and calculate that right away. So I'm gonna cross this up here because this is where our final answer is gonna be displayed. So we have 1, 0, 0, which stands for 4. Add 0 to fill the space up, and we have 0 here, 1, 0, 0, which stands for the next 4. So that is 4, 4, 2, 2, 4, 4, 4, 4, 2, 2. So which we have here in our question. So let's go ahead and answer that. Good. So for the 4422, this we are using the OR gate. That means one person should meet this thing. So here, none of them meets this thing. That is for this. So we're gonna drop 0 for them. This one of them at least one person meets. We're gonna put 1 for them. This one, at least one person meets. Good. We're gonna put 1 for them. Or this one, nobody meets. 0 for them. This particular one here, nobody meets, so 0 for them. One person meets here, 1 for them. At least one person meets here, 1 for them. Nobody meets, 0 for them. So we end up having 0, 1, 1, 0 and 0, 1, 1, 0, 0, 1, 1, 0 for this side and 0, 1, 1, 0 for this side. So you can see 0, 1, 1, 0, if you can remember, it stands for 6. So we have 6 here and we have 6 here. So you can see that. So our final answer is this 6, 6, which we have here. So you can see that. So question number 12, going. Question number 12, we have 8, 9 and 0, 1. Okay. So let me put 8, 9 and 0, 1. So 0, 1 is going to be that 0, 0, 0, 0. That's for the 0 family. Then for 1 is going to be 0, 0, 0, 1. Like that. You can see that. So that's for this particular one here. Now, for this other one here, we have 8, 9. So let's go for 8, 9. 8, 9. 9 here is going to be 1 0 0 1, and 8 is going to be 1 0 0 0. So you can see that. So we are using the AND gate. That means two people must meet the condition. So 1 1 here, one person meets. These two, nobody meets, we put 0 for them. Nobody meets, put this one, only one person meets, we still put 0 for them, because we at least the two of them compulsory. 0 0 0 and 0. So you can see we end up having one person meeting here and one. So for this one here, this particular one we have here is 1, and for this particular one we have here is 0. So our answer is going to be 0 1. So that's our answer. So the correct answer here is what we have here as 0 1. Good. So number 13, the same thing to applicable 8 8 and 0 1. So we have 0 1, which is going to be 0 1 2 3 4, then slash 8, then we have 1 0 0 0 1, like that. Then we have for 8 is 1 0 0 0, and this is 1 0 0 0, like that. So we are using the AND gate, and the AND gate simply means that at least one person must meet the requirement. No? Sorry, the two people must meet the requirement. So for this 0, sorry, I'm supposed to put that here, not there. Okay, so for this guy, 0, because only one person meets that. 0 0 0 0, in fact 0 0 0. Just like you write nonsense the first time, maybe the teacher has marked like the first 20 people and none of them is writing something sensible. You're trying to write something meaningful, and the teacher was like, in fact, let me just give 0. So he does not even care, because the teacher is already fired up. So everybody ends up having 0 0 0. So nobody meets the requirements. So that's for this one. Number 13 is 0 0. So number 14, we come to the shift right. Shift right. Good. So for the shift right, we're not going to be doing more. So 0 2 stands for what? Let's look for 0 2. 0 2 is what? Let me bring my pen. 0 2 is 0 1 2 3 4, which stands for the first value, which is 0 there. Then for the 2, we have what? We have 0 0 1 0. That is 2. So 0 and 2. So you remember this in our previous class. That's the value. 1 and 0 stands for 2. So we just fill up this remaining part with that stuff there. Okay, so we're going to be shifting it right. 1. So shifting it right is moving it towards this direction. So move it. So 1 is going to move to this direction. So when that happens, our final answer is going to be 1 here. 1 have moved, to this place. Then the next one we have there is what? 0 0 0. This 2 0. This 0 is for this 0 here. You can see this one is for this one here. This next 0 that comes in is for this other 0 here. I put another 0 again, which is for this other 0 here. You can see another 0 again, which is for this 0 here. So you can see that the next 0, which is for this next value here, we have here. So you can see that there we now have another extra 0, which is a replacement of the thing we have here. So we are replacing that 0 because there's nothing here. So we have 0, 0, 0, 0. Sorry for that. So you have 0, 0, 0, which is the first one. 0, 0, 0, 0, which is going to be 0. And we have 0, 0, 0, 1, which is going to be 1. So we have 0 and 1. So that's our final answer, 0 and 1. 0 and 1. So that is it for this one. 15, 16, 17, 18. Oh, we have a lot here. So shift right. So let's do number 15. Shift right. So I'm going to do number 15, then I'm going to skip number 16. You do that yourself. I'll skip this. You figure out that yourself. Then I'm going to jump to number 18 and number 19. So let's do the shift right number number 15. So we have 8 and 9. We have 8 and 9. 8 and 9. So 8 is what? 8 is 1, 0, 0, 0. That is 8. 9 is 1, 0, 0, 1. That is 9. Okay. So we shift it 3 times to the right. So shifting it 3 times to the right, this is going to be out, this is going to be out, this is going to be out. So we're starting from this one we have here. That's where we're starting from. So we now have 1. Okay, let me clean that. We now have 1, which is for this one here. We now have 0, which is for this 0 we have here. We have another 0 for like that, 0 like that, 0 like that. Okay, sorry, how many? 1, 0, 0, 0. So I think we have 3 0. So get rid of this. 1. So stands for the other one there. We have 0, 0. So you also know that this is out because it has been shifted right. So they have disappeared. So it's just like there's a gate here. There's a gate here. So those 3 have entered that gate. So what is remaining there is 1, 0, 0, 0, 1. That's what is remaining. So to fill in those gaps, let me get rid of this so the thing will look neat. So those 3 is gone. So this is what we are left with, which is the 1 and the 0. Because those 3 numbers have entered this gate. This is a gate. They have entered the gate, so we are left with a single 1 and 0, 0, 0, 0, 1. So to make it, because it's 1, 1, 2, 3, 4, 4 numbers. So this is another number here, starting the next number. I'm going to put demarcation there to demarcate it. So that's for the first set of numbers. The next number is only 1. So we just add 3 zeros to fill in those gaps. You can see that. So at the end of everything, we have 0, 0, 0, 1. Then your line. Then we have 0, 0, 0, 1. So you see we end up having 1, 1. As you can see that. At the end of everything, we have 1, 1. So you can see the correct answer to this is the 1, 1 we have there. This 1, 1 over here. So, so I'm going to be skipping this because we have done that. We have done this. Actually, I think this number 17 will be kind of complicated. So I have less minutes. I have close to 30 minutes. More than hour and minutes, going to the 30th minute now. So we have 13, 1 and 3. So we want to remedy that. So moving it to the right, 13 1 is what? 0 0 0 1, that is for 1. 3 is what? 0 0 1 1, that is 3. So if we move it how many times? Once to the right, is going to add another 0 here, then this guy is going to be erased out. So automatically we now have what? 0 0 1 0, which is for these first four numbers. Then we have 0 1 1 0, like that. So I hope you get the concept here. So 0 1 1 0 stands for 6, and 1 0 0 0 1 0 stands for 2, so that's 26. I think I saw one. Okay, is not it. Then for this one, I'm going to be doing number 18. I'm going to be leaving number 19 because 18 has letters, so I want to figure out how those letters come into play. So for instance, we have the tidal sign, which stands for what? The NOT gate. That is the opposite of everything. So if you have 1 in the NOT gate, it's going to be 0. If you have 0, the NOT gate is going to be 1. So it's always giving us the opposite. So we have 0x12. So we're concentrating on the 12 alone. So to get that, we have 0 0 0 1, that's for the 1. Then for the 2 we have 0 0 1 0. So the NOT gate is going to give us the opposite, which is NOR. The tidal is going to be what? The opposite. So where we have 0, we put 1 there. 0 1 1. You can see that 0 1 1 1. You can see. So you get is always the opposite. Now we want to get rid of all this stuff here because this is the main value, the main number we are looking for. So this number, we're asked to convert it to hexadecimal. So what's going to be the real value in hexadecimal? So we're going to convert this 1101. So this is going to be I think this is going to be 1. Sorry, 1. This out 2. This 4, and this is 8. So 8 plus 4 plus 1, that's going to give us what? That's going to give us 13. So there is 13. So that's the value for that. So this side stands for 13. Stands for 13. Then this side, let's see. We have 1. Sorry, it's out because it's where 0 is. Here is 2. Here is 4. Here is 8. Okay. So we have 2 plus 4. 8 plus 4, that is 12. Plus 2, that is 14. That is 14. So we have 14 here. So you can see we have 14 and 13. And I tell you, in hexadecimal, we don't have 14 and 13. They are represented with letters. So 13 means what? 10 stands for A, 11 stands for B, 12 stands for what? For C, 13 stands for D. So 13 is a D. Then 14 will be what? E. So it will be ED. So you see our final answer is ED. So that is that for this tutorial, and thank you for staying with me till this time, because you staying with me till this time means you are really interested in learning, and you also subscribing to this channel means you are giving me the zeal, you are giving me the ginger, you are giving me the swagger. In fact, you are giving me the energy to do more. So please stay tuned for the next um, tutorial I'm gonna be dropping on how to what writing a function that converts a binary number to an integer, which is converting binary to base 10. So that's the next stuff we're gonna be talking about. The next stuff we're gonna be discussing in our next class. So stay tuned, and I hope you guys enjoy and understand this. God bless you and have a nice day.